Hello friends, welcome to Bindu Dhadwal chemistry lessons. The topic that we take is adsorption and its types. The branch of chemistry which deals with the nature of the surface and species present on it is called surface chemistry. Adsorption may be defined as the phenomena of higher concentration of the molecular species, gases or liquids on the surface of the solids than in the bulk. Supposing you take a piece of chalk and you dip it in ink solution and then you break the chalk into two parts, you see that ink is present only on the outer surface of the chalk and inner one is still white. The solid substance on the surface of which adsorption occurs is known as adsorbent, while the molecular species that get adsorbed on the solid surface due to intermolecular attractions are called adsorbate. If we take a gas in a container which is corked and we measure its pressure, let it be P, then in the same container when we put a piece of charcoal and leave it for some time, shake it, stir it, and then again measure its pressure decreases. This is because the charcoal has adsorbed the gas. So similarly, in a blue litmus solution, when charcoal is put, the color fades after some time because the blue color is adsorbed by charcoal. Or the raw sugar is brown in color and put charcoal powder in it and filter the solution and crystallize. The sugar that comes out is colorless because the color of the raw sugar has been adsorbed by the charcoal. This is adsorption in action, mechanism of adsorption. A solid surface has a few unbalanced forces on its surface. This is because the inner valencies are satisfied because of bond formation, but the surface valencies are left free. So these surface valencies, they get occupied when molecules of the adsorbate get attached to it. The force of attraction between the adsorbate and the adsorbent is weak van der Waals force of attraction. What is also seen is that the extent of adsorption increases with the increase in surface area. If you break this metal surface into pieces, then you see new unbalanced forces come on the surface, and so the adsorption increases. The concentration of adsorbate is more on the surface than in the bulk. This kind of adsorption is called positive adsorption, and if the concentration of adsorbate is more in the bulk than on the surface, it is called negative adsorption. Adsorption is of reversible nature. If an adsorbed species has a tendency to come out of the surface, then this reverse phenomenon is called desorption. Increase in temperature increases desorption because they break the bond between the adsorbate and adsorbent. Absorption, the phenomena as a result of which the molecular species of one substance are accumulated on the surface as well as inside, that is throughout the substance, is called absorption. You can see in this diagram the difference between adsorption and absorption. Water and silica gel is placed. Water is adsorbed only on the surface, not in the bulk. This is adsorption. And anhydrous calcium chloride will take in water on the surface as well as inside. It gets soaked with water. This is absorption. So absorption is uniformly distributed, whereas adsorption is concentrated mainly on the surface. In absorption, concentration is same throughout. In adsorption, concentration is more on the surface than in the bulk. Adsorption is a surface phenomena. Absorption is a bulk phenomena. Absorption occurs at a uniform rate. Adsorption is rapid in the beginning and the rate slowly decreases. Sometimes both adsorption and absorption occur simultaneously. This is called sorption. Adsorption, there is a decrease in residual forces on the surface. This decrease in energy is released in the form of heat. So reaction is exothermic. So the change in enthalpy that takes place for adsorption of 1 mole of adsorbate on the surface of adsorbent is called enthalpy of adsorption. The reaction is exothermic, delta H is negative. But because the gas gets attached to this molecules, its randomness decreases, so T delta S is negative. So negative of negative is positive. So for delta G to be negative, for reaction to be spontaneous, the whole answer should be negative, and if temperature is large, then this term may exceed delta H. So in order that reaction should be spontaneous, the temperature should be low. So what you see is adsorption is favored by low temperature. Types of adsorption depending on the nature of forces. Particles of adsorbate are held to the surface of adsorbent by physical forces such as van der Waals forces. It is called physical adsorption. These forces are weak and can be easily overcome by increasing the temperature or decreasing the pressure. So the physisorption is reversible. It can be reversed by increasing the temperature. For physisorption, the enthalpy of adsorption is also low, between 20 to 40 kilojoules per mole. The characteristics of physical adsorption, it is non-specific in nature. Any gas can be adsorbed by any solid. Physical adsorption depends upon the nature of gas or adsorbate. This in turn depends upon the magnitude of attractive forces between the adsorbent and the adsorbate. Gases like ammonia, hydrogen chloride, carbon dioxide, sulfur dioxide, which are polar in nature, they are adsorbed to a greater extent. The order of extent of adsorption is hydrogen least, and it increases in the order. Nitrogen will adsorb more than hydrogen, then carbon monoxide, methane, carbon dioxide, HCl, ammonia, and sulfur dioxide is adsorbed to the maximum. Gases like hydrogen, oxygen, nitrogen are liquefied with difficulty, so are adsorbed less. Ease of liquefaction of the gases can be compared in terms of their critical temperature. Critical temperature is the minimum temperature above which a gas cannot be liquefied, however large its pressure may be. Greater critical temperature means more is the magnitude of attractive forces between adsorbent and adsorbate, more is liquefiability, and more is the extent of adsorption. Then physical adsorption depends on nature of adsorbent. The adsorbent having more surface area will adsorb more. It depends upon the activation of adsorbent area. Hence, activity can be increased by mechanical rubbing, strongly heating with superheated steam. Steam will pull out the gases entrapped between the pores and thus make it more active, and adsorbent is subdivided into fine pieces. Then also adsorption increases, adsorbent is activated. Enthalpy of adsorption is low, of the order of 20 to 40 kilojoule per mole. The reversible nature, if you increase the temperature or decrease the pressure, adsorption can be reversed. Physical adsorption can be reversed. In the nature of molecular layer, the gas can be adsorbed in multimolecular layers if the pressure is high. Chemical adsorption. When the molecules of adsorbate and adsorbent are held together by stronger forces similar to chemical bonds, adsorption is known as chemical adsorption or chemisorption. It leads to the formation of some sort of compounds on the surface of adsorbent. These are known as surface compounds. For example, when oxygen is adsorbed on tungsten, the chemical bond is formed to such an extent that when the bonds are broken, the molecules which are released are tungsten oxide. That means they have bonded together. And similarly, when oxygen is adsorbed on charcoal, the molecules that come out are carbon monoxide or carbon dioxide compounds. The main characteristic of chemical adsorption are, it is specific in nature. Enthalpy of adsorption is quite high, 80 to 240 kilojoule per mole. It is irreversible in nature. Increase in surface area also increases adsorption, and the nature of molecular layer is monolayer. Only one layer is formed. Differences between physical adsorption and chemical adsorption. In physisorption, the nature of forces are weak van der Waals forces. In chemisorption, it's strong bond forces are present. Enthalpy of adsorption is low, 20 to 40 kilojoules per mole. In chemisorption, it's high, 80 to 240 kilojoule per mole. It occurs at low temperature, it occurs at higher temperature. It is reversible, it is irreversible. Physical adsorption is non-specific, it's highly specific. In physisorption, multimolecular layers are formed. In chemisorption, monolayers are formed. Extent of adsorption is directly related with the ease of liquefaction of gases. There is no correlation between extent of adsorption and liquefiability of gas. Activation energy is not needed in physical adsorption to a great extent, whereas appreciable activation energy is required because it's a chemical bond that is formed. Then state of adsorbate is same as that in bulk, whereas here it may be different from that in the bulk.